Okay, so we've looked at solving quadratic equations with factoring. We've looked at solving quadratic equations with um, the quadratic formula, and now we're going to solve quadratic equations by completing the square. So I guess the goal or the first trick is to kind of know that you're still doing the same thing. In the end here, we still want to find out what x equals. What values for x can I find that are going to make my equation true? Okay, so whether I factor or whether I use a quadratic formula, whether I complete the square, we're all looking for the same thing. It's just different methods that you can choose at your convenience to do that, to solve for x. Okay, so before we start with actually completing the square, I just wanted to show a couple of simple equations here. Okay, if I have x squared is equal to 4, okay, I know that I can take the square root of both sides of these, and that there's actually two numbers here that satisfy my equation. When I take the square root of 4, that's going to give me either plus or minus 2. So there's two. This is actually a quadratic equation, right? I can say that if I put plus 2 in for x, it's going to equal 4. And if I put minus 2 in for x, it's also, that squared is going to equal 4. So that's a true equation. Another way that I can solve that, x squared is equal to 4, is to rearrange and factor it. Okay, so I could write it like this, right? X squared minus 4 is equal to 0. I could factor that out as a difference of squares. X minus 2x plus 2 equals 0. And now I can see from my factors what my solutions are. X is equal to, what makes this factor 0? It looks like 2 will. What x makes this factor 0? Looks like minus 2 does. So there's two ways that I can go ahead and solve for the same equation. Okay, but still getting the same answer. So it's really important that no matter what method that you use, you realize that your end goal is just to find an x. So that when we go through completing the square here, that's what we're trying to find. We're trying to solve our equation by finding for x. Okay, but before we get to that method right away, we have to talk about binomial squares first. Okay, so a binomial square, you guys have seen these before, square, is something that looks like this. Let's go with x plus 3 all squared. Okay, this is a binomial that's squared, and in its expanded form, it looks like this. Those two things are the same. Okay, so when we go to complete the square, it's the same thing, because I can see that if I expand out here and I multiply or do my FOIL, I'm going to get x squared plus 3x plus another 3x gives me 6x here, and then finally times 9 gives me makes this binomial squared expanded out into this trinomial form. Okay, and what's nice about this in this form is that I can do a square root of it. Okay, so if I have x plus 3 all squared, I know that the square root of that is equal to x plus 3. So when I see this binomial squared in its factored form, this seems to be like a little bit more of an obvious choice. It looks like I can take that square root and it'll give me that. But when I see this, it's kind of hard to imagine that the square root of this is also equal to x plus 3. Okay, so we want to find it in this binomial square form. Okay, so the way how this helps us when knowing this, the way that helps us when we go to complete the square is that if I've got an equation that I want to solve, let's say I've got x squared minus 16x is equal to 15. Okay, and I want to solve this equation. So we're going to go ahead and complete the square here. All right, so what I'm going to do is I'm going to say I don't know how to take the square root of this side with this side because I don't have a perfect square here. So what I want to do is I want to build one of these binomial squares out of here so that I can get this nice, binomial square in there that I can take the square root of and get an answer for. Okay? So the way that I do that, there's the magic formula here, right? So here it is. I want to take b divided by 2 and square it, and that's going to complete the square for this trinomial. Okay, so b is my minus 16, so I'm going to go minus 16 over 2 all squared. And what does that give me? Minus 16 divided by 2 gives me minus 8 all squared. And if I square that out, it gives me plus 64. So if you're doing this little trick, you always know you're going to get a positive answer because it's going to be squared. It doesn't matter if the number in here is plus or minus. So in this spot right here, to find our c, I'm going to put in plus 64. Okay? And because this is an equality, okay, I don't want to change my equation here at all. Okay, I just want to make it look prettier. So what I'm going to do, if I add 64 to this side, I've also got to add 64 to this side as well. Okay, to keep the equation balanced. All right. Now, but look what happens here. Okay, I can factor my trinomial as a binomial square now. Okay, so if I factor this out, what numbers multiply to 64 and add to minus 16? Well, minus 8 does. X minus 8 and x minus 8 is this term factored out. And that's what we're doing. That's why this is the completing the square step. Anytime that you apply this little formula to the middle term and add it to make another term to your trinomial, what's going to happen is you're going to make a binomial square. Okay, so it's always going to turn out to be, I put this just so you could see how it was factored, but it's really x minus 8 all squared is equal to, and then this side 15 and 64 looks like it gives me 79. Okay, and this is a nice little trick here because now what I can do to solve my equation is I can take the square root of both sides. Okay, and so this square with this square root is going to cancel, and I'm left with just x minus 8 is equal to, and you have to remember here, I took the square root, so just like we did way up here, okay, I'm going to get two answers for that x. Okay, I got plus and minus 2 here. When x squared was equal to 4, I knew that there were two answers that were going to work, the plus and the minus part of it. So the same thing is going to happen down here. Okay, I'm going to get plus or minus the square root of 79. Okay, so what's x? Okay, let's get x by itself here. So I'm going to go over here and write my answer. I'm going to add 8 to both sides, so x is going to equal plus or minus the square root of 79 plus 8. And that's it. Okay, so let's try another example. Let's go with 2x squared plus 20x minus 8 is equal to 0. And we're gonna do this one by completing the square again. So what I want to do is I want to isolate my two x terms to one side. So I'm going to add 8 to each side. So I get this. And you know what? I can do a little shortcut here. If I see that there's a greatest common factor, I can divide each of these sides by 2 to make my work a little bit easier. So I'm going to divide by 2 here, divide by 2 here, and I'm left with x squared plus 10x is equal to 4. Okay, so what I want to do is I want to complete the square here so I can make my binomial perfect square here, so I can take the square root and solve for my x. So the way I do that, again, I take the middle term, the x term, 10, I divide it by 2, and I square it. So that 10 divided by 2 gives me 5 squared is equal to 25. Okay, so I'm going to add 25 to my equation there, and because it's an inequality, I have to add 25 here as well. Okay, so now I've completed the square. So I factor this, and knowing that I made a binomial perfect, I know I can put in x plus 5 there, all squared. Okay, so I guess if you wanted to factor it, you could say, you could find your two numbers that multiply to 25 and add to 10 here, but because of what we did here, we know it's going to give me a perfect square. Okay, so I can do this step if I want and say my two numbers that add to 25 or multiply to 25 are 5 and 5, and they both add to 10, but I know that this is going to happen. I'm completing the square. So I know I can skip that middle step. I can always go from right here to here. Okay, so that's all equal to x plus 5 all squared is equal to 29. Okay, and now I want to solve for x. So I take the square root of both sides. Okay, and on this side, my square side is going to cancel out with my root sign, and I'm going to get x plus 5 is equal to plus or minus the square root of 29. So to finish, I'm going to go x is equal to, and I'm going to subtract 5 from both sides, so I'm going to get minus 5 plus or minus square root of 29. Okay, and that's really two answers, right? I've got, here they are, which means that x is equal to minus 5 plus root of 29 and minus 5 minus the square root of 29. So I got two answers for my quadratic equation, which is kind of the way we want it. Okay, let's finish off with one last example here. Okay, let's go with, okay, we'll just separate that up here. Let's go with another example. We'll say x squared plus 12x minus 4 is equal to 0. Okay, so this one, I know I can't factor it. There's no numbers that multiply to 4 and add to 12. So I want to choose a different method. So I'm going to use completing the square here. So what I'm going to do is, yeah, let's put up here, solve for x. Okay, I'm going to isolate my two variable terms on this side. So I'm going to add 4 to both sides and come over here. And now I'm going to find the number that's going to complete my square. Okay, so I'm going to find this number here that's going to complete my square. So 12 divided by 2, all squared. Well, 12 divided by 2 is 6, and 6 squared is equal to 36. So I'm going to add 36 to this side. And to keep the equation equal, I'm going to add 36 to this side. And I'm going to rewrite and simplify, well, factor, I guess. I'm going to rewrite this trinomial as the binomial perfect square that we created. So x plus 6 all squared is equal to 40. Okay, so now I'm going to solve for x, right? So what do I want to do? I want to take the square root of both sides. So my square cancels with my root sign, and on this side I get x plus 6 is equal to plus or minus. Now 40 has it's 4 times 10, so the square root of 4 is 2. I can rewrite this as 2 roots of 10. And now all I want to do is isolate for x. So x is equal to minus 6 plus or minus 2 roots of 10. Okay, and if I want to write those answers out separately, I can say minus 6 plus 2 roots of 10 and minus 6 minus 2 roots of 10. Okay, and there's your final answer. So practice those 3 examples there and get in the habit of finding that third term that's going to make your binomial perfect. And yeah, just give them a go.